All right, so we are on practice test 1, and we are ready for problem number 6. Now, what is happening with number 6 is we're arranging 10 people, but now we are arranging them in a circle. Does anybody remember what that happened, or what changes? What happens when we arrange things in a circle? What? Exactly. That is exactly right. We reduce it by 1. So instead of having 10 factorial, which is how we would arrange 10 people in a row, now we're going to have 9 factorial. So you will write down, you can write down 9 factorial, but then you gotta type that in, and 9 factorial is 362,880, right? Okay, here we go again. What should I see on everyone's
Calculator.
Calculator. Exactly.
Yeah.
You guys know how wild and crazy my E period is, but yesterday every one of them had a calculator, and so they got a bonus point.
You just be
And
handing
if
bonus
E
out like
period
this.
can do it, you people can do it. All right, let's go.
You people had a full pack yesterday.
Get out your calculator, type in 9 factorial, and what does it say? 362,880?
Yep.
Okay, Kendall, Blake, we have no linear, and we have no calculator. Is that right?
That's 3 today.
Well, we got some lotion. All right, how many committees consisting of 3 boys and 5 girls can be formed from a class of 10 boys and 8 girls? So it doesn't really sound like it, but this is the same as your card problem. Instead of having jacks and kings or red and black, now we have boys and girls. So we have a total of 10 boys and 8 girls. I'm gonna reach into this pile right here and pull out 3. So 10 C3. There are 10 boys, and I am going to pick 3 of them. And why is it a C? Because order doesn't matter. I'm just grabbing 3. Then I'm gonna reach into this pile and pull out 5 girls. Since I am doing boys and girls, what am I gonna do with these 2 numbers?
Multiply.
Write this down. And is multiply. Okay. And is multiply. What word is the add word? Or. Or is add. And is multiply. So these are getting multiplied. So we're going to type in 10 C3, and everybody is typing. Do you not have a calculator pen? Okay. Do you remember what happened yesterday when we got the 3 strikes? Okay, head down. 8. 5. I got 6,720, is that right?
Yes.
Perfect. 6,720.
Bro, they gonna watch that YouTube video, right?
probability of being dealt a 5-card hand that is composed of all diamonds? All right, this is a probability question. So as soon as you see the word probability, you should think fraction. What is going to go in the denominator since it is a 5-card hand?
52C5.
52C5. Now what's going to go in the numerator since I want all diamonds? All diamonds. 13C5. That's exactly right. Please do not try to cancel anything. The only way to do that is to type it in. Remember, you always kind of got to be on the lookout for these little tiny numbers in scientific notation. We got one. 4.95 198 times 10 to the negative fourth. Do not put 4.95. Remember, this is a probability question. The answer has to be less than 1. So 4.95 doesn't make sense. 4.95 times 10 to the negative fourth. All right? Okay. Another probability question. What is the probability of being dealt a 5-card hand? All right, what's my denominator? 52C5. If it's a 4-card hand, it's 52C4. If it's a 10-card hand, it's 52C10. That's your denominator. Now, what's the top? I want exactly 3 aces. How many aces are there total? 4. And I am going to pick 3 of them. Is that okay with everybody? So far, we're not done. This is another tricky one. Why are we not done? There's 2 more cards. Now, what do the 2 more cards have to be? Anything except an ace, right? So how many cards in the deck are not aces? 48. 52 total, 4 of them are aces, 48 other cards, and we want to get 2 of those other 48. And since you are getting 3 aces and 2 others, what are you going to do here? Multiply. Your calculator will do all of that at once. So you don't need to mess around with parentheses or anything like that. If you don't want to. Did you get .00174?
Yep. Get that here? It's .00174.
All right, number 10. Number 10 isn't going to be like this, is it? What is number 10 going to be like? What am I going to do with number 10? Make a tree. Make a tree. Read the question. Remember, on test day, which will be in a couple more days, a couple more class periods, you won't have me up here telling you to draw a tree. You have to be able to tell that's a tree problem. What are the 2 things happening in the problem? Rain and tennis. The question is, what's the probability I'll play tennis? So the first level of the tree is rain and no rain. And then the second level is the tennis. how do we decide what goes first? It's what the question is not about. The question is about, is find the probability of playing tennis. So tennis has to be on the bottom. All right, let's start plugging in some numbers. If it rains, the probability I'll do tennis is 0.15. Are you okay with that? Now, the minute I put 0.15 on this, what's this? 0.85. If it doesn't rain, the probability I'll play tennis is 0.9.
God bless.
Now, I put 0.90, 0.9 is fine. And the minute I put 0.90 here, I'm going to put 0.10 here.
Yep.
Remember, each little v has to add up to 1 or 100. The probability of rain is 0.45. So that means the probability of no rain is 0.55. Right? And now I want to know the probability I'll play tennis. So that is, here I'm playing tennis, here I'm playing tennis. So who remembers what we do now? We have everything all set up, now we have to actually do the math. What do? We multiply this branch right here. This is a tennis branch right here. This is rain and tennis. So we're going to multiply 0.45 and 0.15. And we are multiplying those because it's raining and I'm playing tennis. And then I'm going to come over here. I don't figure out what that is. Come over here, and now I have to have this branch. This is not raining and playing tennis. So I'm going to multiply those two things together. And these two things and these two things. And then I'm going to add them because what's happening, guys? It's either going to rain and I play tennis, or it's not going to rain and I play tennis. So I got 0.5625. Anybody else get that? All right, read number 11 and tell me what you think we ought to do with number 11. Is number 11 going to be a tree diagram?
No.
No. What is number 11 going to be? A Venn diagram. Absolutely. It's going to be a Venn diagram. What have I got? I have a box of seniors. There's 50 of them. And what are they doing? They're singing and they're praying. Now, be careful. How many of you enjoy singing? 25 hands go up. How many of you enjoy praying? 32 hands went up. Now I have a problem. You can't put 25 here and 32 here. Why? That's more than 50. So what does that mean? Someone voted twice, right? I got 57 hands that went up, 57 votes from 50 kids. So 7 of you voted twice. Now I know how many are here because the whole singing ball is 25. 7 of them are there, so the other 18 are over here. The whole praying ball is 32. 7 of them are here, so that's 25. And now I can answer the question. How many enjoy only praying? 25. All right. All right, this one is an expand problem, and I noticed as I was grading your homework, and by the way, quite a few of you did not turn in the 9-2 homework.
Wow.
So you might wanna take care of that. But the ones that did, some of us had an issue, so let's go through this really carefully and make sure that we're on target. I'm gonna check my attendance one more time, make sure. Seth, Evan, and Miles are the only ones I counted for. All right, who remembers? What do we do? This was before, a long time ago. Who remembers? No one remembers? Well, we gotta start by writing out a list of numbers.
X.
The list of numbers, since this is only to the 4th power, I think I'm gonna find the list of numbers using Pascal's triangle. So remember how we build Pascal's triangle? Put a 1 on each end, and then what goes here? 4, 6, 4. And that's all I'm gonna build, because 4th power, 4th row. So I'm gonna write down those numbers, 1, 4, 6, 4, 1. All right, and then do you remember what I do?
Put the X to the 4.
I write down an X and a negative 2Y. Space that out very well. So, guaranteed test question, right? It's on the practice test. You need to know what to do. So the first thing we do is write down our numbers. The easiest place to get those numbers, not the only place, easiest place, is from the Pascal's triangle. So I wrote down my numbers. Next to each of them, I wrote down the 2 parts of my binomial, which in this case are an X and a negative 2Y. Okay? Now do you remember what to do next?
Put an X to the 4.
Put on the powers, that's right. And right here, on this X, right here, we start with a 4, and then we count down. And then what about the Y's?
Count
Same thing. You can either count down from this end or count up from this end, whatever's easiest for you. And we observed that in every term, the exponents add up to that. All right, now I'm going to put plus signs to separate my terms, always plus. Now some of them might turn out to be minuses, but they start out as pluses. And then I simplify each term. What happens to the 0? It's gone, right? It's 1, it's gone. So all I have is x to the 4th. to start with. Now be careful. This involves some multiplication. So what's going to happen here when we multiply it all together? Negative 8 x cubed y. How did I get negative 8? 4 times negative 2, and then x cubed y. All right, what about here? Now this one is tricky, be careful. I have my 6x squared, and then I have what? What's this? 4y squared. Right? And that makes 24x squared y squared. Notice it all gets multiplied together. This is a multiplication here. There's no minus, no add, it's all multiplied. All right, you do this one. What's that one? When you multiply it all together, what do you come up with? Actually, negative 32, because you have your 4x, and then you have times negative 8y cubed. Negative 2, negative 2, negative 2 is negative 8. Multiplied. So negative 32 xy cubed. Good. I did not leave much space here. This is all a term right here. That goes away, right? Remember, when they're to the 0, just ignore them. And what is that then there on the end?
16y to the 4.
16y to the 4. 2 times 2 times 2 times 2 is 16. 4 negatives are going to make a positive. All right, anybody have a question about one of those? Good. Number 13. Stop yawning. Number 13 is really the same kind of problem, only it's a lot easier because instead of finding the whole thing, we're only finding the third term. So it would be like finding just this part, the third term. Okay? We're going to go through exactly the same steps. So the first thing I need to do is figure out the number I'm going to use. Like here I use 6. I need to figure out what number I'm going to use. Now you have a choice.
7c7.
You can go ahead and do your triangle. Now, from the previous problem, we already had it built this far. So then here's the 5th row. Here's the 6th row. And here's the 7th row. And I want the third number, so it would be 21. So that is one option that you always have. You always have that option. So the number I'm going to use is 21. Now, if you don't want to write all the triangle to get to that number, then you can remember that this number right here, the first number, is 7c7. That number is 7c7. This number is 7c6. And that number is 7c5. And if you type in 7c5 on your calculator, it'll say 21. Alright, so you can do it either way. Once you figure out what your number is, next to it you're putting a 2x and a y. Those are the two parts of that problem, 2x and y. Now you need to put your exponents on. Well, if we started, Los, where's your line? If we started writing out the whole thing, then on the first term, it would be x to the 7th. Here it would be x to the 6th, and here it would be x to the 5th. So the power I need on my x is a 5. And as soon as I put a 5 on there, I know this one is 2, because they gotta add up to 7. And now I'm going to simplify. Be careful, when you simplify, it isn't 21 times 2. It's 21 times 32, because that is 2 to the 5th, which is 2, 2, 2, 2, 2, 32. So I'm getting 672 x to the 5th y squared. That is the third term of the expansion. Does anybody have a question about that? Okay, this whole test is calculator, but you are being asked to do AC5 by hand. So what work has to be shown? Just like in your homework, what work has to be shown? Who remembers the formula for HC5? You people remember anything? There we go, Bo.
8 factorial over 3 factorial, 5 factorial.
It is exactly that. 8 factorial because of this. 5 factorial because of this. And where did the 3 come from? 8 minus 5. Right. So then we write out 8, what 8 factorial means. And 8 factorial means 8, 7, 6, 5, 4, 3, 2, 1. And that's over 3, 2, 1, 5, 4, 3, 2, 1. Well, guys, what is going to happen every time? What's going to happen? A whole bunch of stuff is going to cancel. So this is going to cancel, and that's going to cancel. Now, what's 3, 2, 1? 3 times 2 times 1. So that will cancel with that. And the only thing that's left is 8 times 7, which is 56. So, for this question, that button's on your calculator, okay? But you're not gonna get credit unless I see this and this. All right, that's the work. You can check it on your calculator. If you type in AC5, does it say 56? I hope so. All right, 15 is one of these ones with the weird notation that we talked about yesterday. So let's see if you can remember what to do here. So we have our apples and bananas again. And we know the probability that somebody likes apples is 0.7. So the whole A ball is 0.7. The whole banana ball is 0.5. And who remembers what this means? That is A and B, so that is the part in the middle. So 0.3. Right? Now, the minute you put that 0.3 in there, then what do you know about this?
0.4.
0.4. And this is
Point
0.2. Now, these are probabilities. We know that all of your probabilities have to add up to what? 100%, right? So what have we got here? 0.4, 0.3, and 0.2 only adds up to 0.9. So there's 0.1 outside the circles. Those are the people that don't like apples or bananas. Now we're ready to answer the questions. What does this mean?
They like apples. but
A
not-
and not B. I like apples, but not bananas. So how many is that? Where is that? Apples and no bananas. 0.4.
Not
What does this mean?
Don't like both.
Don't like either one of them, and those are these guys out here that we figured out were 0.1. All right, and here we go. We got a chart. This is just like remember the very first thing we did in this unit, or in 9.3, was the M&Ms in the bags. This is the same thing, only it's kids in classes. Assume that one student is chosen at random from each class. What is the probability that both like math? So in other words, I want math and math. What does that and tell me? All right, what's the probability I get a math kid out of class 1? 60%. I'm just gonna say 0.6, but you can say 60% if you want. And then what's the probability I get a math kid out of class 2? 0.4. Now I'm gonna multiply those, and I'm gonna multiply them very carefully, or on my calculator to make sure I don't make a careless error, 0.24. So the answer to question A is 0.24. B, I want math and science, okay? So class 1 likes math. First kid likes math. That would be 0.6. And second kid likes science, that would be 0.2. So your answer is 0.12. Jack, you awake, sweet pea?
Yeah.
What is the probability neither likes art? So not art and not art. Alright, so class 1, what's the probability of no art? 0.9. Kids, if 0.1 is art, then the other 0.9 are not arts. And then how about class 2? 0.9 again, so 0.81. All right, and then the very last problem on this practice test. Very last problem. Probability that one will like science, so science and English. So 0.1, 0.3, did you get 0.03? That is not the answer. Can somebody tell me what's going on, Mary? Do, because it doesn't say first science and second English, it just says one of each. So could it be science and English? Absolutely. But it could also be English and science. And that would be 0.2 times 0.2. Read question B and read question D. Do you see the difference? D can be either order. So in other words, I could have this situation, or I could have this situation, which means I'm going to do what with these two numbers? Add them. So the answer is 0.07. All right, we gotta be on our toes. All right, here we go, practice test 2.
Woo. Just flying through it.
We are flying. Here we go. Number 1. Read the question. Don't say anything. Let everybody read the question. Write down what you think it is. Write down something. And then let's hear some ideas. For question number 1 on practice test 2. How many sandwiches are possible? How many different kinds of sandwiches could I come up with? Anyone have a thought?
24.
I heard 24. How did we get 24?
Multiply all together.
Multiply all of them together. Guys, it's like my jumpers and shirts problems. I gotta go down there to the cafeteria and I have to pick a bread. How many ways can I pick a bread? 3. And I have to pick a meat. And I have to pick a cheese. So how many total sandwiches? 24. Okay? No factorials. I'm not arranging anything. I'm picking. How many ways can 10 different chairs be arranged in a row? 10 factorial. I don't know what that is. That's a big number. 10 factorial. Remember, you do have to give me an answer. 10 factorial isn't good enough. Did you get 3,628,800?
Yep.
3,628,000. Where's your calculator? All right, type it in yourself.
I got a little nervous there. I'm like,
Yeah, you should be.
Making him nervous.
All right, how many ways can you answer 5 multiple choice questions? All right, so you are going to answer 5 questions. Here they are. These questions are multiple choice, and each question has 4 options, so like A, B, C, D. All right? So yesterday it was true and false. Today it's 4 options. So, how many options do I have for this question? 4. And 4, and 4, and 4, and 4. So the answer is whatever 4 to the 5th power is. 1,024, he says. 1,024. So do you remember yesterday's question was multiple choice? And we did 2 times 2 times 2, or not multiple choice, true false. And we did 2 times 2 times 2 times 2, right? Well, this is exactly the same problem, we just have more options. All right, number 4. How many ways can I give away 4 identical blue markers in a class of 12? So I have 4 markers that are all exactly the same. I'm gonna give them away. There's 12 kids, 4 of them are gonna get a present. Is that gonna be 12 P4 or 12 C4? C4. Why is it C4? No order. The prizes are the same. Charles doesn't care if he gets the first marker or the second marker. They're exactly the same. Now, what if the markers were different colors? Then it matters. That would be 12 P4. Because Charles has a favorite color and he wants to get that marker. Right?
Yep.
Okay. So what is 12 C4? What, 195, 495, 495? So remember, on test day, you are writing down a number in the answer blank. So 495. How many 10-letter words can be formed from toothpaste? What do we do first? Step 1. Count them up. There are 10 of them. So we start with 10 factorial. If all the letters are different, then we're done. 10 factorial is the answer. But what do we got here? 3 T's. So that's a 3 factorial. 2 O's. That's a 2 factorial. And that's it. Now let's everybody type this in and make sure we can. You get half credit for the setup and half for the answer. So you don't want to mess around and get the wrong answer. Did you get 302,400? Carson, is that right?
Wait.
Yeah, we got
I didn't get that.
Didn't get that, let me try again. I think that's right.
What'd you get, 1?
10 factorial.
Wait, I got 1
million?
1 meal.
Divided
I
by
got a meal.
3 factorial.
Like 108.
Oh, you gotta divide each of them?
Oh my gosh, yes, you have to divide by each of them.
Oh, let's not.
Remember, this is, okay, type 10 factorial.
Yep.
10 factorial.
Yeah, divided by
Divided by 3
3 factorial,
factorial.
divided by 2 factorial.
Divided by 2 factorial.
Yeah,
What did you get?
hold on.
Okay.
Yeah.
You had the L before.
You guys are driving me over the edge. Number 6.
Oh,
How many ways can 5 people be seated around the dining room table? 4 factorial. Because when you seat 5 people in a row, it's 5 factorial. But when you put them in a circle, it's 1 less, 4 factorial. 24. 24. Because of rotations, we explained that one day. How many teams consisting of 2 seniors and 3 juniors can be formed from a group of 8 seniors and 6 juniors? All right, take a second, put down your thought. What thought do you have about this problem? Ty, I want everybody writing something down. Have a thought. We're all using pencil, we can erase if it's the wrong thought, but let's have a thought. We've done one of these already today, only it wasn't juniors and seniors, it was boys and girls.
Oh, so 2.
This is exactly like the boys and girls problem we did before. Who had a thought that you're willing to share?
You tried.
Carson?
So I did 8C2 and then 6C3.
8C2 and
6C3.
And what did you do with these two numbers?
Oh, I got 28 and 20 and then.
And got 560? I don't know if that's right or wrong. What do you guys think?
That's what I did. Right.
That's what you did? Why 8C2? Because there's 8 seniors and you're picking 2? And 6 juniors and you're picking 3? And why are we multiplying those? Because you are picking seniors and juniors. So that's a multiply. What is the probability of being dealt a 4-card hand that is all red? Okay, now wait, it's a probability. You gotta stop yourself, make sure you have a fraction. Probability. It's a 4-card hand, so what's my denominator? 52C4. 52 cards, picking 4. That's your denominator. Now what's your numerator? They're all red. No, not 39.
26.
How many reds are there? 26.
Right, 26 minutes ago.
Remember, the deck has 4 different kinds of cards in it. They're called suits. 2 of them are red and 2 of them are black. So half of the cards are red. Do not simplify that. Try to simplify it, and you gotta type it in. Oh gosh. I got a bigger answer than I thought. Did you get .055?
Check it out.
Yeah.
So what that means is there's about a 5.5% chance that they'll happen. That if I hand you 4 cards, you have a 5.5% chance of getting all red. All right, we'll stop there. For those of you that know what the schedule is like coming up, I don't.
It's bad.
Wait, I see you tomorrow.
Yep. And then you see us.
You don't leave me? Y'all be safe.
Friday.
Yeah, you say I'll be taking pictures for y'all. Me and Lonnie gonna click up for
It's gonna be
y'all.
like Monday.
We're gonna mail it to you.
Wait, which word? What does it mean when it says like?
That's times.
So this word is times six?
But that number needs to be written out, so you need to figure out.
Oh, it's for your ring's really nice.
Thank you.
Me and Lonnie's gonna mail you